Welcome to Vintage Radio Cafe, your #1 channel for relaxing vintage audio restoration. If you like watching an idiot wielding a soldering iron, you've come to the right place. Watch Ray's attempts to fix wonderful forgotten radios from another era, way before transistors. Sometimes he even gets them working again. What could go wrong, right?
Okay, folks, so it's the end of the afternoon, and I spent a few hours putting the chassis in the chassis holder, and it's not the same dimension, so I had to drill new holes, and it's always like that. And I removed the filter can, the main filter can, which was here. You might not be able to see it. It's the same principle as, well, I want to say as always, but they're probably not always made like that. The can is ground. There's 250 in there, 250 UF microfarads. And the can sits on top of the chassis, and between the can and the chassis, there's a ring. And that's all that guarantees the ground return. And interestingly, I'll try to show you this if I can. There's no wires. Sometimes there's an additional wire from this ring going to the ground to make sure it's well grounded. It's not in this case. Well, no matter if there's a glare, I just want to show you the continuity. Okay. Look at that. It's dirty, the surface rust. Some places it doesn't work at all. What kind of resistance do we have? Yeah, it's all over the place. Not good. So we'll clean this. I don't know if this alone can explain what we're seeing, the deportment we're seeing on the dim bulb. It does look like the capacitors were never really charging. So maybe that's part of the issue. So we'll clean it. We'll see what we can do with that. And I forgot to mention, I pretty much gave up on the wafer switch. There's no way I can get them out without dismantling the whole radio. And but I cleaned them again. So it's the 4th or 5th time I cleaned them. So I want to show you the electrolytics. And I'm telling you right away, they're not bad. I already knew that because I tested them on the chassis in circuit. So they should be 50s. .6, something like that. For one, let's test the other one. Should be about the same. Yeah, 43. So the capacitance is not the issue, but most likely they are leaky. I tested them on this guy, which I do not trust. I think since I had it for like a year, there's only one capacitor that this thing indicated as being bad. So it's too general. It says I get what, 0.5 something ESR, and they say good if capacitor is under 200 microfarads. So come on, not the same thing. 50 and 200, too general, waste of money. Plan is to clean this. Yeah, you can see the surface rust. It's a bit better on the top side, but not by much. See, it doesn't look too good. And it's wavy, so it has to touch only those 4 points. So they have to be absolutely clean, absolutely perfect. I know it's high voltage, is probably the voltage is going through, but I just want to make sure. So I'll clean them. We'll do a test after that. This guy. So I'm going to clean the ring, gut this guy, put new capacitors in, and we see what we get from there. I'll get right back to you. Okay, guys. So I've been working for the last hour and a half on the can, yeah. And yeah, I can tell you it's been a hell of a job. Maybe you won't be able to see this, but this can is made by Siemens, okay, just like one here from Grundig. But yeah, probably it's because of the year of production. But this one, this metal is way, way heavier. Not the same gauge. It's very, very hard to see how better this one is, the thinner one, compared to this one. Yeah, it's not as malleable, not as flexible. And so much so that I had to invent something again. Since, yeah, I had to use different sizes screwdrivers to bend the metal there. I had to protect the threads because I have to screw it back on, you know. So they're all okay. And in order to protect them, not to break them with the screwdriver, I took a piece of metal, made a little ring out of it, so I could put 2 fingers here and work my way around without damaging the threads. Yeah. So I'm just about to gut it now. I can tell you, already I know it's pasty, it's no more paper in there, it's just dust. So I'm going to put a little bit of well, I'll cut the leads, cut the negative and the positive, and I'll put a little bit of WD-40, let it work in for 10-15 minutes, and then I'll try removing, cutting the inside with a corkscrew. Yeah. Let's try that. So all the material is out of the can, and it went okay. It was a bit stiff, but the W40 does help. And I just want to see what shape it's in. It's hard as rock. The base, it's not the top, it goes like this. The base closest to the heat is really dry. It seems wet because I use WD-40, but it was really dry. Here you have the contacts, the positive for each capacitor. and the negative lead. Let's see if it's still like paper. Yeah, it's not so bad. No, it's actually good. Well, good. I'm sure it's leaky, electronically leaky, but I've seen worse. Seen much worse. Yeah, shielding's okay. But 65 years in service. Yeah, don't cheap out. Change them. So I'll restuff this in the morning. I'm going to use 47s again. Not sure if I'm going to use the same can or maybe it'll be easier with the grinding. Diameter is the same. Size is the same. It's just the this band here. That's a little bit lower on the one branded grinding. Basically, they're about the same size. 47s will fit either way. Yeah. I'll sleep on it. I'll decide in the morning. So let's hope it improves things. If not, well, I'll start working on the rectifier right away. And if that doesn't work, then I don't know. We'll keep troubleshooting, guys. Catch you in the morning. Okay, guys. So I decided what I was going to do with the main filter can, and I'm going to use the old Grundig one that I had on hand, simply because the ridge here is a little bit higher, so it'll give me just enough room to be able to insert it inside in the right spot, and I'll have just enough room to cap it off with the contact cap. And yeah, the other one wasn't made the same way. I won't have enough room. See, there's a 1/8 of an inch difference. So this one will fit better my needs for this project. Yeah, and I'm going to be using one of those, one of Manuel. Let me just move in closer. Yeah, one of Manuel's old board, designed exactly for that, to use two capacitors. And the way this works, the positive side, all the green part, is connected to those contacts for C1 and C2. And the bottom part, the white part, is all the negatives and also the ground. So I can use one wire going up and out of the can to touch the can to make the whole can negative. And the other ones, I can just put wires there, and also going up to the connectors. So I'll have separate wires, separate colors, so everything is safe and not touching. So that's the idea, and it should look something like that. Well, there's one on top, one at the bottom, and yeah. Let's just see what we have on the multimeter. Yeah. Let's just check if all those connections will be all right before I put the wires in. So let's put this on capacitance. So if it's connected right, well, my black lead is going to the ground, and the red lead is going to one of the capacitors. And at C1, I'm getting 44 point something. So let's try on C2. Should get a different reading. Similar but different. Yeah, 4368. So this is working as it should. So I'll do the connections and reassemble the can, and I'll come back with you once this is done. Yeah, be right back. Okay, folks, so welcome back. It's the next day. Yesterday I spent most of the afternoon just restuffing the can, the filter can. And yeah, I had to do it twice because I told you guys I wanted to use this one, the Grundig one, because it was a little bit higher. It would give me a little more space to work. But the base is different. The base is, this part is shorter. This is why it was giving me more space. But since the base of the original one is a screw-in type, well, I have to respect a certain depth, and with this part being not the right size, well, plain and simple, I was missing a few threads and the can wasn't touching the chassis, so I was having no ground. So I had to redo this, and but now it's all working fine, and it was just a bitch to refold this. Yeah, almost impossible. Metal is still so thick around here. Yeah, I couldn't do a good job. But it's making contact. It just doesn't look as good. But it's better than one that doesn't touch at all, right? So now it's touching. It's okay. Let's just see the capacitance, which will now be summed up since this resistor or two resistors have been connected to the positive of one side. So now I should be getting twice the amount. The two capacitors are summed up. So 95.76, I should get 100 total. That's close enough. It's really good. So what I did is, at the same time, while I was there, because I knew the rectifier was, yeah, I pulled out the rectifier. I knew it was bad. And yeah, so let me just get set up on the tripod. I'll show you exactly what I mean. Yeah, give me a second. Okay, folks, so here's the situation with the rectifier. It's completely dead. Just let me show you. There's no surprise there, but it took me a while to realize the what the flickering dim bulbs was all about. I think this is the reason. So we're in diode mode. Nothing. Absolutely nothing. Okay. So what I have here is a one of Manuel's Designs boards for just capacitors, you know. But I'm going to try to use it just to hold, yeah, the old diode here, and connect the two wires of the rectifier on each side. And if I have to put a resistor, a dropping resistor, I'll put it across here, C1 and C2, and put the outgoing wire on this side. You know, the negative here and the positive here, if I can fit it inside of this rectifier can. But let me show you how. First of all, this diode should work. I put the positive. See, if I do the reverse, not getting anything. So again, this is how it should work. So this is not rectifying anything. It's letting all the AC go through. And yeah, let me just open it up and we'll see if there's any way we can fit this inside. Yeah, we'll try that. So yeah, here's the rectifier, and let's try to open it up. I've already loosened the tabs here. So this should come out. Still pretty tight. It was like this in the on the chassis. The negative, the positive at the bottom. And two wires were connected there. There's a phenolic plate. try to remove gently. So yeah, the selenium plates are here. Contacts are there. Let's try to remove them gently. Oh boy, it's stuck to it. Oh yeah, because there's a little tab here. Okay, just realized this. Okay, I get it, I get it. So, let's get rid of the selenium plates. So the two contacts. The frame that holds everything together. And there's an isolation plastic, plus there was another contact on top of it. So yeah, I don't know if this is still good or not. I have to test it, otherwise I'll put some tape there. So yeah, is it possible? Fit it like that. I think it's going to be too thick. Yeah, strike like this. Yeah, this is going to be the problem. Yeah, it's already higher. Unless put it upside down. It's still a tad high. What about this? Yeah, it's a little bit too thick, but there's a possibility there. Yeah, maybe I can just cut away. Yeah, if I cut away those plastic tabs, maybe I'll be able to do something. Yeah, just to sink it a little bit. I have to cut those 4 tabs. Yeah, I'll have a look at that. I'll be back if I have a brilliant idea. Okay, folks, about 4 hours later, this is what I came up with. So first of all, let me show you it works. Let's go in diode mode. And we now have a functional half-wave rectifier. Now let me show you how I managed to do that. Let's move in just a little closer. See what we're talking about. Yeah. So as I said, I used one of those little boards, little PC boards from Manuel Caldera, who designed them, made by PCBWay, used for capacitors, but I decided to try to fit it inside this half-wave rectifier. Let me open it up for you. It's pretty tight, I'm telling you right away, but it was already tight when I got it, when I opened it first. So this is the top plate. Let's take the phenolic protector off. I'll remove the inner board, and yeah, this is the original insulation plastic polymer of some sort. I put extra electrical tape in the back, and this is what I got. So what I had to do was to, I used a Dremel. So I Dremeled out the little tabs there. And yeah, when you break those things apart, because they're connected to the main rectifier board that they come with, there's always a little bit of a tab that protrudes here, and you cut it with a pair of pliers or snips. So I kept a little bit here because there was a cutaway there. So it keeps it aligned perfectly, doesn't rotate. And what I did, maybe you can see it here on this one, see how high the diode was? So I couldn't close the box, the can there. So what I did, again, I Dremeled my way through on each side. I just moved the diode a little bit more to the center. I Dremeled it and I sunk it. It's countersunk like that, so it doesn't protrude at all anymore. So there's a nice little cutaway in the center here. So I soldered the diode first, and I absolutely wanted to reuse the contacts. So what I did is I soldered them directly to the board. I just had to cut a little bit of it to make sure it didn't touch the other contacts. So it's soldered in place. It's firm, it's solid. So all I have to do now is, put it back in the can, connect the two wires, and it should work. So yeah, good idea, but there's a problem. If I have to drop the voltage, there's no more room left to be able to put a dropping resistor. I mean, I could, I guess, cut a bit of the part, or because on top I can fit it just about anywhere. Here the positive contact is on this side. Let me reverse it. It's on this side at C1, and those are all connected to C1. Those are all connected to C2. So what I could do is, well, my external wire here, I could just link this to make my first test, like I do with a full wave rectifier. I just put a lead or a piece of wire, so the circuit is complete, it's closed. Or if I need a resistor, I remove this and I put a resistor across here, like that. But it's a very short distance. I could always go here. It's a little bit longer, but it still has to go on top or even at the bottom. Now everything is flush. So let's pray I won't need to insert another resistor. If I must, I suppose I could redo just this part and make another cover, bulging, raised a little bit. Maybe I could do that and still save this. or run a wire and put it externally in something, I don't know what. So we'll see when we cross that bridge. Next step is to test this thing, if it works. And since I already replaced the filter can, you're not supposed to do that, you know, replace two major parts, especially in the power supply, and then do a test. But I'm fairly confident the capacitors will be okay. This will be more touchy though, because of the voltage. The silicone diode doesn't typically drop as much voltage as the selenium ones. But the last two radios I didn't even have to put in resistors. Not sure why. Maybe it's because the transformer doesn't output as much anymore after so many years. I don't know. Doesn't seem likely, but I don't have a better explanation so far. So yeah, this is what I came up with, guys. So catch you when I do the next test. Okay, guys. Now, do I have something interesting for you? Listen to this. I finished rebuilding the rectifier, and I did some tests, and nope, I was still having the same flickering, same power fluctuation. I couldn't figure it out. So I decided, yeah, let's have a look at the switch, at the plug. I mean, it was beautiful. It's not something I've ever seen before. I don't know the brand, I don't know the model, but hey, it looked perfect. So I was trying to figure out how it worked. So I couldn't see any access point aside from removing this little cover. And yeah, it took a lot of strength to pull it out, and it was long. It was like never ending, coming out, out. And it finally came out. It's a polarized plug, which you don't need for these radios. And it's not grounded, obviously. And yeah, I was trying to figure out how it was made inside. Let's just go on autofocus. Yeah, I couldn't see anything inside. No screws, no nothing. So I tried to pull on this to no avail. And then I tried pulling on that, and it just came out like that. Look at that. I'm not kidding. Jesus. Let's try to go even closer. So it's never been stripped, okay? The wires are just pushed in like that. And see here? So the way this works, the bands there, the metal bands, when you insert this, it just compresses on each side, and there's little grabbers, pins there that go through the insulation. That's it. That's the only contact points. I can't believe this. Okay, and again, I don't like to criticize the guy before me, and I won't. Because in his defense, you can't find anything here in Canada for some reason. You have to get everything from Amazon. There's nothing in the stores. I just came back from a big hardware store, big surface, big boxes, and they had a couple of those left. That's it. That's all they had. They also had, yeah, right. They also had one model like this, angled one. Which, you know, I took one. I picked one up just in case I ever need it. So I got a couple of those. Those are easy to install, just 2 screws. But the hole is pretty big, so I'll try to, I don't know, use those rubber grommets there and some tape probably, which I'm sure it's going to be, well, it's going to give more contact, better contact to the prongs, pretty sure. So I'll try that, and if that's not the issue, that's not the cause, then guys, I do not know. I don't know what's wrong with this radio. But let's try this, okay? So yeah, I'll get back.